Hi, my name is Connor McAlary, and I'm going to be doing a presentation on the Tachyglossidae family, which are spiny anteaters and echidnas. So a little presentation outline. I'm first going to give a brief description of the paleoecology of this family, the evolution and the extinction, as well as the adaptive radiation, past geographic distribution, the current geographic distribution, the range expansion and contraction, as well as some limiting factors to their range. So a little paleoecology. There is little known about the history of the echidna, as they are still a very secretive family. The earliest Zyglosis fossil record dates back to about 15 million years ago and was found in a mine in South Wales, Australia in 1895. Fossils have also been discovered to have a carbon date of about 100,000 years ago, and they were found in Mammoth and Norcote Cave in Western and Southern Australia. These findings indicate that the species most likely originated in Australia and distributed itself via diffusion due to the connectivity of continents in the Pleistocene era. And this monotreme species is responsible for the eventual evolution of the Tachyglossidae family, and species have been evolving steadily since the early Pleistocene era. So a little bit about the evolution. So until a recent breakthrough discovery using genomic sequencing, there was very little known about the evolution of Tachyglossidae. These monotremes were assumed to diverge from therians about 187 million years ago. And from this, the two monotreme species, so the platypus and the echidna, diverged from each other 55 million years ago. And the diversion of the platypus and echidna came as a result of niche competition. So the platypus filled the aquatic niche while the echidna took advantage of the terrestrial alternative. And there's a theory that has a little bit, but not much support due to physical similarities between monotremes and Australian Diprotodontia marsupials, that this could be a possible evolution route as well. So the extinction of early monotreme species has been presumed to occur due to the replacement of more fit species in existing and filled niches. The early monotremes were outcompeted by species that evolved to have specialized traits that gave them an upper hand in resource competition. So the earliest form of echidna, Megalobguelia, became extinct due to its need for moist, temperate environments, and increased aridification in southern Australia eventually wiped them out. The extinction of two Zyglosis species, Zyglosis heceti and Zyglosis robustus, occurred in the late Pleistocene about 11,000 years ago, and this was presumed to be due to glaciation and human influence such as hunting and Anthropocene habitat loss. Their adaptive radiation. So the main trigger for the adaptive radiation for Tachyglossidae species originated from the ending of the Pleistocene. The end of the constantly fluctuating climate of glaciation, deglaciation over and over again opened up the opportunity for increased specialization and niche opportunity. So the stable conditions rapidly speciated the existing members of Tachyglossidae into forms that would outcompete its ancestors, such as Zyglosis robustus and Zyglosis heceti. This speciation represent the currently extant members of this family, such as the Western long-beaked echidna and Sir David's long-beaked echidna, the Eastern long-beaked echidna, and the short-beaked echidna. The current extant species within the family Tachyglossidae reside predominantly in the southern reaches of Australia, but can be found across the entire country. Echidnas can also be found on Kangaroo Island and Tasmania, most likely a result of sweepstakes dispersal from Australia, or presumably through the connectivity in Gondwanaland continent composition. New Guinea also harbors species of echidna and is likely to have been a result of the previous mentioned occurrences, such as sweepstakes dispersal or connectivity due to Gondwanaland. The past geographic distribution. So there's a lack of wide-scale knowledge on previous species of Tachyglossidae, and the knowledge of past geographic distribution is very minimal. Fossil evidence shows that the echidna family had a range that was almost identical to that of the present. So on Kangaroo Island, Tasmania, New Guinea, and Australia, the range may have been slightly larger in New Guinea and Tasmania due to its presumably higher population densities, along with the apparent shrinkage of current Tachyglossidae habitat and range. So that leads to a little bit of range expansion and contraction. The state of echidna species is in a very heavy decline, with the exception of the short-beaked echidna. The vulnerable and critically endangered status of the Sir David's, Western, and Eastern long-beaked echidna displays a range that is in immense contraction. The main effects that attribute to the decline of the species range are purely human driven. So this includes land development for the use of commercial and residential infrastructure, which results in the fragmentation and elimination of habitat. The expanding agricultural industry results in deforestation, which destroys essential resources and habitat for all Tachyglossidae species. As well, hunting of the species for food by indigenous and non-native peoples is removing already scarce breeding individuals from each population. So a couple limiting factors that affect the distribution of this species is due to the development of specialized attributes. There are many dietary, physical, and habitat-related limiting factors. First, the echidna has a wide territory, yet their mobility is limited to a mere 2.3 kilometers an hour due to their large burrowing claws, gaudy limbs, and heavy defense spines. As well, echidnas require a specific habitat, which includes uninterrupted forest cover, that is old age, in order to supply downed woody debris they use for cover. And the woody materials also needed to supply their diet of insects, which are in particular ant species. The echidna is also very climate sensitive and requires a semi-moist temperate environment that is reliant on regular cyclic seasonal conditions. And Anthropocene development is another massive limiting factor for the species, all within the Tachyglossidae family. So here's all my literature cited. I appreciate you listening to my presentation. Thank you very much.